Hello, this is a video for the final project of EE599 Deep Learning class, Spring 2020 at University of Southern California. We are Group 22 and our project is Deep Grammar Corrector. First, I would like to explain the problem to solve of our project. We are interested in grammar error corrections, which is a task to correct any type of errors in a sentence, such as spelling, word choices, or even some punctuations. We will use recurrent neural network architecture in our project. Comparing to the traditional machine learning approach, deep learning is able to build an end-to-end model. There are different kinds of end-to-end models in natural language processing, in which we will use the encoder-decoder model. It can be formulated by the equation below. We use two datasets for training. One is the Co-NLL 2014. The second one is the Land 8. There are more than 1 million sentences in total. Each of them contains more than one error. The basic idea of our projects is to use different types of models to compare their performance. We constructed our baseline model using the simple LSTM sequence-to-sequence model. The second model we choose is the sequence-to-sequence with attention model. With the help of attention mechanism, we expect it to have better performance than the baseline model.
So here, we also use transformers to build another experiment for comparison. And we use the transformer model from this paper, and then we do some small hacks or small engineering hacks to this model to make it more efficient. And in our implementation, we also use some other techniques to help us to improve the model size and help our model to generalize better. Here, the first technique we use is byte pair encoding. The byte pair encoding is a technique from comparison algorithm. And with these techniques, we can reduce our vocabulary size from 141,000 to 9,944 for the input vocabulary size. And also, we reduce our output vocabulary size from 125,000 to 9,592. And furthermore, if we use the vocabulary sharing, which is also embedding sharing techniques, we can well reduce our vocabulary size to 15,000. Here is the embedding sharing mechanism, and we share all the three embedding: the input embedding, decoder output embedding, and decoder input embedding. And we also have some comparison about the embedding sharing scheme. And for the transformer model, we do some engineering hacks to this model to make it more efficient. And the hacks we use is we move the normalization layer, which is after each sublayer in transformer, and we move that to the front of each sublayer. With this techniques, we can our model can be trained more smoothly, just like here. We can show that with this techniques in the training process, the loss can well reduce and quickly reduce. And here is our experiment result. The baseline model can achieve a validation loss of 2.2. And with embedding sharing, we can show that our model can reduce the parameter size about 33% compared with the model without using embedding sharing. And for LSTM model, we can achieve the best validation loss of 0.943. And for transformer model, we can show that the model can achieve a validation loss of 0.883. In a summary, the transformer model is outperforming the LSTM model with attention. For evaluation, we use GLEU score to evaluate our model. We also compare our model with a model which is using traditional machine learning techniques. And this model is from this paper. This paper is also the paper of GLEU. And we can show that our best model, the best transformer model, can achieve 0.68 GLEU score for the CONLL 2014 test sets. And if we combine the test sets of LAN 8 and CONLL 2014, we can show that the GLEU score can reach to 0.69. This two score outperform the traditional machine learning model and our baseline model. And finally, we go to our demo.
Now I would like to show two inference demos of our best transformer models. First, let's confirm the parameters of the model. We can see that the embedding dimension is 256. Next, we enter a sample sentence and input it to the model. There are 3 errors in the sentence: missing comma after the word world, missing a word R after the word price. The word price also should be in plural form. After processed by the best transformer model, the 3 errors are all corrected. Let me show one more sample. In this sample, the word got and pricing are all well corrected.
And in our demo, we have shown that transformer model can perform well for many sentences, but we also find that sometimes transformer model can fail. And firstly, we can see as line 3, this sentence is apple is still by 3 feet. There are 2 grammar errors here. One is for still, and the other one is for thief. So we first run the transformer model to see the results. We can see that the transformer model can correct the grammar error of thieves. However, it cannot correct the grammar error of is still. And then we run the LSTM model. This LSTM model is the best LSTM model we have trained. And we can show you once. And just like the model is shown here, model 7, which achieve a validation loss of 0.94. Here, we run this model and can see that LSTM model can fix the grammar error of is still. And finally, we ensemble these two models to make it a better model. This is our ensemble function. And we firstly create our sentence using transformer model, and then we create this sentence using LSTM model. And here is the ensemble result. We can see that this sentence is perfectly correct by this ensemble model.
This concludes our final project of EE599 Deep Learning class. Thank you for your listening. We would also like to thank the Amazon Educate program for providing cloud computing resources at AWS. Thank you.